Okay, so describe the M behavior by filling in the blank spaces, and then you're going to state the degree and the leading coefficient of each polynomial. State the domain and range in interval notation for part A only, and part A is the only one that had it anyway, so that should be good. So in order to do the N behavior, you have to look at the degree and you have to look at the leading coefficient. The degree is always the highest exponent. So this is 5. The leading coefficient is the number in front, so this is 2/5. What you have to analyze is if the degree is odd, the ends go in opposite direction. So ends go opposite. If this is positive, okay, then it goes up on the right. Did you have to write this part down? No, you just had to execute it for this. I'm just giving you some extra notes so you understand why we're doing this. And I recommend doing more of these for practice because you should know how to do this in any situation, not just if it's odd and positive. When you're filling in the x's, the first one is always negative infinity, the second one is always infinity, because you're saying what happens on the left and what happens on the right. So the leading coefficient tells you what happens on the right. It's going up, so it's positive. The degree tells you if they're the same or opposite. If they're opposite, this is positive, that one has to be negative. How'd we do? Okay. Now this says we have to do the domain and range. What's the domain? All real numbers. So negative infinity to infinity. That's what it is in interval notation. Is the domain ever not all real numbers? Nope, it always is all real numbers. Okay, the range for this one is all real numbers. Is it always all real numbers? Nope. When is the range all real numbers? That's when it's not. Yeah, so when is the range all real numbers? When the degree is odd. Yep, so range is all real numbers for the odd degree, and then it says when is the range not all real numbers. Okay, so yes, it's when the degree is even, but do you guys know the two cases? Yep, so it's either going to be from 0 to infinity, okay, and that's if a certain situation happens, or it can be negative infinity to 0. Okay, if the degree is even, on your chart it says less than or equal to 0 or greater than or equal to 0, and I'm going to show you that in 4.1. I highly recommend that you retake a look at 4.1. So what we have is this chart. Okay, on the chart it says for evens, they're either greater than or equal to 0 or less than or equal to 0. Okay? If they're greater than or equal to 0, what ends are the directions going in? If they're greater than 0, where are the ends going? Up. So if they're going up, the leading coefficient has to be positive. Okay? If it's below 0, then it's going to be negative. So this is saying they're all above 0. Okay? Or 0 and above. Okay? And this is below 0. Okay? So know the situations for that. Positive leading coefficient, negative leading coefficient. All right, so for B, we have to find the degree and the leading coefficient. The degree is always the what? Yes, okay, so the degree is the highest exponent. A lot of times it's first, but it doesn't have to be. In this case, isn't this the highest exponent? So your degree is 4, okay, and that means your leading coefficient is -8. Do not forget the negative. Okay, so sometimes it's not in standard form. You have to check that. Then again, you are analyzing. Is this even or odd? And if it's even, the ends go in the same direction. If this is negative, then it falls on the right. So again, when you're filling this out, negative infinity, positive infinity. As x goes to positive infinity, that's the right side. So if it falls on the right, it's negative. And then if they're going in the same direction, this has to be negative. Okay, how did those go? All right, so write 2 examples of expressions that are polynomials. So I wrote x to the 5th minus 3x squared plus 1. I wrote a trinomial. And I wrote a binomial. 1/2 x to the 5th minus 6x to the 6th. Those are a few examples. Okay, so be able to identify polynomials there. Okay, now it says write, and again, 2. Okay, so write 2 examples of expressions that are not polynomials and explain why they are not. Okay, so some of you guys did a good job of giving 2 different examples. If you didn't give one where you have a variable in the denominator, I do recommend writing mine down. Okay, and then there are 2 explanations that you could have for this. Okay, so this is not a polynomial because you can't have what? Good, you can't have a variable in the denominator. I think some of you or one of you just said denominator. Okay, we got to expand on that. So denominator is not enough. Okay, that's just a word. I need a sentence. Okay, and it does have to be variable. So you can't have a variable in the denominator. Okay. Oh, and then did some of you put or can't have a negative exponent? Yep, that's fine too. Can't have a negative exponent. You could even write an example with a negative exponent if you wanted. All right, and then another one that we talked about is when you have this root, right? We did a square root. I decided to switch things up so you can see different examples. So this is not a polynomial. And again, it's all about the variables. So not a polynomial because you can't have a variable under the, and then what do we call this? Yeah, the radical. Yeah, if you guys said root, I would count that right as well. Okay? All right, so make sure that you review those and you know those rules. Use the graph to estimate the number of real zeros. The real zeros are just the what on the graph? X-intercepts. Great. Okay, so we're going to count them. This one's kind of tricky. You have 1, 2, 3, 4, and 5. Okay, and all you have to put is 5. You could put 5 zeros, is fine. All right. This one was a little bit harder than I expected for some of you. You have to identify the degree and leading coefficient and then explain how you know using key terms and evidence. Okay, so again, you need to tell me why the function has an even degree. Okay, so I'm going to show you my answer. Okay, so if you look at the ends, both of the ends are going in the same direction. So you just need to say the function has an even degree because the ends are going in the same direction. See how I underlined the key terms. So even degree, so you have to say it has an even degree because the ends are going in the same direction. And really, that's all we know about it. okay? Some of you put a quartic, and that's fine. Just make sure you talk about the even degree. And then the leading coefficient is negative because the graph falls on the right side. Okay, so the evidence is that it falls on the right side. The leading coefficient, you have to have that key term. So key term, and then the evidence is just what's happening in the graph for that. Okay? For B, the ends are going in opposite directions, so you just say it has an odd degree because the ends go in opposite directions. And then the leading coefficient is positive because it rises on the right. So again, leading coefficient, positive, rises on the right there. And like for this, if you didn't put it in complete sentences here, I'm not worried about that. It's just I want you to be able to explain how you know if it's odd, right? What from the graph tells you it's odd, the opposite directions. All right, what questions do you have for me on those? Feeling good about odd and even, positive and negative leading coefficient?